Hello everyone, myself Sai Prasad, a lecturer in AhleBait High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We have started a discussion with the chapter Functions. We discussed the basic definitions, then we did few theorems, problems up to the inverse. Today we are going to discuss a typical topic, that is domain and range. What is this domain and range? You people always know that if f maps a to b is a function, then a is called as domain and b is called as codomain, right? And what are the elements which we are going to map from a to b? The set of those elements is called as range, isn't it? We always know that range is a subset of codomain. So we are going to learn what is this domain and what is this range. Clear? Now tell me, for example, if I say f of x is equal to x square, just tell me what all numbers I can substitute in that. I can substitute any value, right? I can substitute it from minus infinity to plus infinity, isn't it? Then what is that I am going to get? I am going to get only a positive number 0 to infinity. Yes or no? Yes, right? Once again let me tell, if there is a function f of x is equal to x square, then what all values I can substitute in it, that is, it can be either negative or 0 or it can be any number positive. I can square it, isn't it? Whatever the value I can square, I will get all the values in a positive range. Minimum is 0. Even if you square a negative number, I always get a positive number. That is, this minus infinity to infinity is a domain and this 0 to infinity is a range. Clear? Is it okay? Fine. If you remember, what are this kind of brackets? Those are open brackets and closed brackets. If you remember, what do you mean by closed bracket? Closed indicates that we are going to involve this term also in the range. And what do this open bracket tells? That is, it does not include this value. Okay, let me tell you an example. If it is 1 comma 2, it ranges from 1 to 2 excluding 1 and 2. What if it is 1 comma 2? Both are under the closed bracket, then it includes 1 and 2 also. Clear? It's clear till this point, right? Fine. So I can tell this as domain of this function and this as range. Okay. What if f of x is root x? Tell me, under this root, do we have any negative numbers? No, right? If x belongs to a real valued numbers, then the domain is always equal to, from where? 0 to infinity. It includes 0. Then what about range? Range will be obviously 0 to infinity. Is it clear? It includes only positive integers. Is it clear? Did you understand what is domain and range? So there are few conditions you have to remember. How do we find and everything is, first thing, if my function is in denominator, then we have to check, we have to solve by taking f of x not equal to 0. Okay. If my function is under root, then I have to write f of x is greater than or equal to 0. Yes or no? Since it is under square root, it should be either 0 or more than that. It cannot be less than 0. Isn't it? Fine. If my square root is in denominator, what is the rule? F of x should be obviously greater than 0 and it should not be equal to 0. You have to remember that also. Clear? Yes or no? What if it is equal to 0? Since 1 by 0 is infinity, we cannot equate it. Clear? Then what are more things? Logarithms. Tell me, log value should be always greater than 0 and never it should be equal to 1. Clear? Whatever the logarithm function is there, it should be always greater than 0 and it should be never equal to 1. Why? Because log 1 is 0. Okay? Which means if it is in the denominator, this condition is satisfied. Clear? These are the basic rules to solve finding domain and range of a given function. Shall we do? Let's do. Look at these questions here. He is asking us to find the domains of these functions. How do we do? If you observe, here the denominator is 6x minus x square minus 5. So, since in order to get a domain, we have to equate this to, that is we have to equate this is not equal to 0. That is, here 6x minus x square minus 5 is not equal to 0. Why? Because if it is in the denominator is 0, then it will be infinity. So, let us write it in a standard format. X square minus 6x plus 5 is not equal to 0. Can we factorize this? Yes, right. 5 ones are x square minus 5x minus x is not equal to 0. X common, x minus 5. Here minus 1 common, x minus 5. If I take x minus 5 as common, I will get it as x minus 1 not equal to 0. Therefore, x is not equal to 1, x is not equal to 5. Therefore, the domain x belongs to R minus 1 comma 5. This is the domain. Is it clear? This means except 1 and 5 numbers, the x belongs to all real numbers. Clear? Fine. Look into this next question. Here it is in the denominator and also it is under square root. Then what is the condition? X square minus a square should be greater than 0 and never should be equal to 0. Remember that. That is, x minus a into x plus a is greater than 0. Now tell me what is the condition? If you remember that limits and continuity, if it is greater than 0, it lies outside the range. X belongs to R minus, what are those? Minus a to a. Clear? That is, we have to indicate this. That is, x belongs to minus infinity to a and a to infinity. That is minus infinity to minus a and a to infinity. Clear? This is my domain. Right? Next, look at this. This is again the place where you have to use your brain. There are two functions, that is a function includes two square roots. This is one and this is one more. That is, for the first one, here 2 minus x should be greater than or equal to 0 and here 1 plus x should be greater than or equal to 0. Then from this I can write it as 2 is greater than or equal to x. Then if I revert it, then I will get x is less than or equal to 2. Isn't it? Fine. Here also x is greater than or equal to minus 1. Now if you observe, here the value of x is greater than minus 1 and it is less than 2. Clear? Therefore, x lies between minus 1 to 2. Both are closed. Right? In some places they write it as x belongs to minus 1 to infinity. Okay? And here x belongs to minus infinity to 2. If I combine these both, I will get this as answer. Clear? Do you understand? Shall we move on to the next problem? Let's do. Look at these questions here. He is asking us to find the domain of these things. 1 by log of 2 minus x. First thing, it is in denominator. Second thing, it is under log. Okay? That is, what is the rule? If it is under log, 2 minus x should be greater than 0. Right? Since it is in the denominator, you have to remember 2 minus x is not equal to 1 because log 1 is 0. 1 by 0 is undefined. So, we have to solve this. 2 minus x is greater than 0, 2 is greater than x, or x is less than 2. And if you observe here, 2 minus 1 is not equal to x, therefore x is not equal to 1. So, therefore, x belongs to minus infinity to 2 minus 1. Yes or no? X is less than 2 bole to from minus infinity to 2, we have to subtract this one element 1. Clear? Next, mod of x minus 3. Modulus of x minus 3. Then what is it? It should be always, whether it is positive or negative, the modulus is always positive. Whatever the value you substitute instead of x, it is valid. Even if you substitute 3 also, it is 0. It is a real value. So, therefore, domain of this is R. Right? See here. Here 1 by mod x, 1 by root of mod x minus x. 2 things, 3 things. One thing is denominator, second square root, third modulus. Clear? Now see here, since it is under the square root, I will write it as mod x minus x is greater than 0 and not equal to 0. Why? It is in denominator. Clear? From this I can write mod x is greater than x. At what condition will the mod x will be greater than x? Tell me. Only when x is negative. That is, x belongs to minus infinity to 0, excluding 0, just before 0, whatever the value it is. Clear? This is my domain. Clear? What if this is in the numerator? Just tell me. If it is in the numerator, I will write it as mod x minus x is greater than or equal to 0. Isn't it? From that, mod x is greater than or equal to x. When it will be greater than or equal to x? Either it will be equal or greater. Greater bole to from minus infinity to 0. Equal or more means obviously it should be a positive value. Therefore, here the domain is a real valued number. Any number you can substitute. It will be either greater or equal. Clear? Is it fine? Shall we move on to the next problem? Let's do. Look at this question here. He is asking to find the domain of this root of 3 plus x plus root of 3 minus x by x. What are different things here? Two functions with two roots and denominator will have one more. Okay? See here. That is, for 3 plus x, it should be greater than or equal to 0. For this, it should be less than or equal to 0. And for this, it should not be equal to 0. Yes or no? Since these both are under roots, those should be greater than or equal to 0. Since it is in the denominator, it is not equal to 0. Right? Now see here, x is greater than or equal to minus 3. Yes? And here, minus x is greater than or equal to minus 3. If I apply minus on both sides, x will be less than or equal to 3. Clear? And x not equal to 0. Just tell me, x is greater than minus 3 and less than 3. So, it lies between minus 3 and plus 3 except for 0. Therefore, the domain is minus 3 to 3 except 0. Isn't it? This is important. You can easily remember. Instead of 3, they will give 2 and you will have one more question like that. Next, let us have a question with box x. That is step x. Tell me, it is under logarithm. What should be the rule? It should be greater than or equal to 0. X minus box x should be greater than or equal to 0. Okay. Then x is greater than or equal to box x. Isn't it? Then I can directly tell box x is less than or equal to x. Right? What is the condition? Whatever the value it is, box x will be always less than x. Okay? Oh, since it is this, so x is a non-integer. Here x is a non-integer. Clear? Therefore, except that we can write anything. Yes? That is, therefore, f belongs to R minus Z. Why? R is a real number, S we have, Z is a integers set. Clear? Now let us think of this. There are different things here. Under root is one thing, there are two functions, and box x is one more. When will that be positive inside a square root? When both numerator and denominators are positive. And second case, both the numerator and denominator are negative. Now let us do the same thing. For case 1, 4 minus x square is greater than 0. Box x plus 2 is greater than 0. Okay. Now let us write from here. 2 plus x into 2 minus x is greater than 0. And here box x is greater than minus 2. Here, if you observe, x plus 2, x minus 2 is less than 0. And box x is greater than minus 2. Why did I write like this? We know this format only. So, x belongs to minus 2 to 2. However, it is greater than minus 2. It's fine. What do that mean? Since it is minus 2 it starts, it can have the value just before that. That is, x belongs to minus 1 to infinity. So, by including these two, I can write it as x belongs to minus 1 to 2. Clear? Let us take second case. That is, both are less than or equal to 0. Okay. Both can also be equated to 0 at once. Next, here 2 minus x, 2 plus x is less than or equal to 0, and here box x is less than or equal to minus 2. Therefore, what is the thing here? Again I have to take common x minus 2, x plus 2 is greater than or equal to 0, and here it is box x is less than or equal to minus 2. Isn't it? Then it will be minus infinity to 2 here, and here x belongs to minus infinity to minus 2 and 2 to infinity. Let us combine those both. What do we get? It is, if you combine these both, it should be common. Remember, therefore x belongs to minus infinity to minus 2. Right? It is minus infinity minus 2, 2 to infinity. If I combine those both, this is a common place. So, if you observe here, x belongs to minus 1 to 2, and here it is minus infinity to minus 2. Yes or no? So, I can write it as x belongs to minus infinity to minus 2 union minus 1 comma 2. Clear? Did you understand? These are few problems of domain. Shall we do a few more problems? Let's do. Look at this next question here. He is asking us to find the domain and range of these functions. We know how to find the domain. Let us do that first. That is, for this function, I know that numerator can be any value. The denominator cannot be equal to 0. Therefore, x is not equal to 2. Right? Therefore, the domain is x belongs to R minus 2. Till there it's fine. Then what about the range? How do we find? Remember from here. Now, let 2 plus x by 2 minus x is equal to y. Let us convert everything in terms of y. Let's see how it looks. 2 plus x is equal to 2y minus xy. Okay. Let us bring this x this side to that side. That is, x plus xy is equal to 2y minus 2. If I take x common, I will get it as 1 plus y. Here it is 2 into y minus y. Let us write it. Therefore, x is equal to 2 into y minus y plus by y plus 1. This is x. If I find the domain of this, obviously that will be the range of my function. What is this? X is nothing but this value. Clear? Now see here. What is the thing here? Y plus 1 should not be equal to 0. Therefore, y is not equal to 1. Therefore, the range is r minus 1. Is it clear? Do you understand? Let us do for next problem. You will have a little more clarity. Here, since it is modulus, obviously it should be greater than or equal to 0. It cannot be equal to 0 because log 0 is infinity. So 4 minus x square should be greater than 0. So 2 minus x, 2 plus x greater than 0. Therefore x minus 2, x plus 2 is less than 0. Therefore x belongs to minus 2 to 2. This is the domain. It's fine. Then what about the range? We have to equate it. Log of 4 minus x square. Before equating it, just have a look. Log of something. Here they are telling we are going to substitute minus 2 to plus 2. Okay. You can do two things. Substitute minus 2. What do we get? 4 minus 4, 0. After minus 2. Therefore it is 0. This is also 0. Then what do we get? Let us check. Is equal to y. Then what do I get there? Tell me. That is e power y is equal to 4 minus x square. What is e power y? Or else you can simplify it first of all. X square is equal to 4 minus e power y. E power will be always greater than 0. Remember, x is equal to under root of that. 4 minus e power y. Now here it should be greater than or equal to 0. Right? That is 4 minus e power y greater than or equal to 0. Therefore, 4 is greater than or equal to e power y, or simply e power y is less than or equal to 4. Isn't it? Is there any kind of condition like that? Tell me. Log y is less than or equal to log 4. Let us write. Okay. Or else y is less than or equal to log 4. What does that mean? Can we have any condition like that? No. Or else you can directly write here. Since e power y is greater than 0, obviously the range is always a real value. You can get anything. Clear? You can get anything. Clear? Fine. These are different problems of domain and range. Shall we do a few more? Let's do. Look at this next question here. This is simple to solve. He gave f equal to 4, 5, 5, 6, 6 minus 4 and g is 4 minus 4, 6, 5 and 8, 5. He is asking us to find f plus g, f minus g, 2f plus 4g, f square and root f. How do we find? That is, you have to check for which both the domains are same. Then only we can add or subtract or whatever. Clear? So here if you observe f plus g, if I want to add these both, I have to check this. Is it clear? See here. That is, the set will be for 4. For 4, you have to add this. Okay? It will be 4. 5 minus 4 is 1. Next, do we have any domain with 5? No. Do we have any domain with 6? Yes, we have. 6 minus 4 plus 5, it is also 1. Clear? Similarly, we have to take f minus g for same thing. 4 f minus g. 5 minus into minus 4, that is 9. 6 minus 4 minus 5, that is minus 9. Is it? Next, 2f plus 4g, that is again 4 same. 2 into f plus 4 into g. 2 5s are 20, 4 4s are 16. 20 minus 4 is again 4. Clear? Next, 2f plus 4g, right? 2 5s are 10, minus 4 4s are 16. 10 minus 16 is minus 6. Next, 2f, 4 2s are minus 8. And 4 4s are, the next here 4 5s are 20, it is 16, 6 comma 16. Next, f square. How do we do? F square is again for the same common terms only we can do, that is for 4 and 6. Is it clear? Or else for the numbers which the square root is possible. Okay. See here, for this 4 root 5 and 5 root 6. Can I write for this? No. Why? Here it is root 4, minus 4. Since minus is not possible under the root, we will not write. Next, this is square root of f, right? Next is f square. I didn't observe. F square is 4, 25, 5, 36, 6, 16. Clear? Is it fine? Is it okay? Fine. By this problems we can end the chapter functions. What did we learn in this chapter? We started with the basic definitions of functions. Then we did few problems on what are the functions, how to solve them. Then we did all types of functions, then specialized functions. Okay. Then we did few theorems, inverse, clear, domain and range. These are the basic problems which are to be used in the future subjects. Clear? Hope everything is clear for you. Fine. This is for today. Let us meet in the next session with the new chapter of 1A. Thank you.